Alright, complete printed circuit board design using Orcad capture layout. Craig Mentzer, Nunez, Chapter 9, printed circuit design examples, Example 4, high-speed digital design. Alright, high-speed digital design. The example to demonstrate the how to check with the layer of the design transmission lines for high-speed digital printed circuit board. For example, I'll demonstrate how to create the molded ground area with the bridge around, how to frequent crystal oscillate with how to perform pin gate swapping, how to create a heat spreader with the free voltage of the ground plane with the example circuit shown in figure 9.122. 119 chain pin pack style, example 3, 120 verifying connection to ground planes, shown per pin. Alright, the bill of materials shown on the table of the line 11 circuits consist of the functional high-speed low and low pin count, contact and count, microcontrol, digital signal processor, UPXCE, XED10 driven as a 66 MHz clock, X1 digital fiber optic integrated circuit FOTX, which mimics the ADN 2530, but with fewer pins, fiber optic laser diode. A couple of 54 ALS 00 and NOR AND gates for IO decoding. Digital signals high rise fall times of 20 parts per second to 1.9 seconds. Figure 921 shows the final altered board design for example 3, and then it shows figure 122 high speed digital circuit schematic. Figure 19911, the bill of materials digital design example. Alright, required controlled impedance raised for the C with the analog devices ADN 2530 data sheet for the example. The application for the real design with a more capacitive will be given the capacitor circuit. But the design scale down, fewer for the 10 parts, fewer for the or equal to 14 pins per the part with allowed give the demo version of the part and the footprints located with the CD with the design digital extension fold with included with this book. Give the procedure described with the earlier example to start with the new project and play with the connection parts as shown. Figure 922 with the completing schematic to make sure that all the footprints assigned with the part of the create with the digital AX and net listing file for layout. Open layout start with the new board project with the procedure that described with the previous example. You can use the technology file 3 beta any technology template technology file which is during the development of board design included within the CD. This reason was chosen with the default trace width of 6 mm, which made it easier for the route with the trace within the small pad with the U2. No matter which file is chosen, some modifications will require the complete design. At the previous example, the first step of the make of the board outline, play for the parts and some of the boundary initial board layout shown in figure 9.123, single flow on the left and the right with a high frequency component located with the close together near the laser diode connector for the right side of the board. And the next step of the cover the detailed previous example, the following table is found show with the design parameters. For example, the step-by-step instructions not required to, but the required steps are 1 to find layer stack with enable the appropriate layers, give the layer spreadsheet, that they make 2 with the net layers, assignment of the net spreadsheet, edit net dialog box. 3 to find 2 Viva addition with the Viva 1 using with the pad stack spreadsheet, the ed pad stack dialog box 4, I hand out the power and ground for surface mounted components. Figure 129 throws initial board layout with design detail design example. Layout set with the microchip transmission line with there's field free parts with a simple 4 layer with the board design with the layer stack up with the assignment of its own figure 9.124. Layer thickness depending on the board manufacturer value with using the mills shown in figures is typical with the top layer with the ground plane, maybe give the route surface types of the microchip transmission, most of the lower speed with digital traces. Only low-speed traces can be routed on the top, will be routed on the bottom layer. So the high ground and low power voltages, prepreg cores, and 10 surface mils, strips, 40 mils for the core. 3 V with the table of 9, 12 with the V with the 1, default with the V with the include with the technology file with the V with the 2, and with the V with the custom V with the smaller shot with the 10 with the pad jacket table with the solid max definition V with the 2 is U with the fan outs, where their small pad sizes allow with greater population density, multiple V with the 3 will be with the heat pipes. To connect thermal pad, a copper area opposite with between the U2 with the ground plane and the function with the heat spreader. Show up the 912 show the list of the VVD with the digital example. We have the 3 red reliefs and floodplain pores. Heat pipes, power ground, fire nozzles, default, pad clearance and drill. View with the design with a heat spreader with the V with the efficient with the conducting heat with the solid connection planes with the U with either rather than thermal relief. Sign floodplain pores view with the insert with the 3 or leave it open with the pad stack spreadsheet with the double click with the V with the name display with the ed pad sheet. Dialog box select with the floodplain pores option. Constructing a heat spreader with heat spreader with a copper up area to opposite with the design of the heat spreader with the PCB. The design significantly type of the device out with the attack of the board with the example. Design example thermal management calculation application of the reference for the appendix F with the heat spreader with the demonstrated here with the base for the digital suggestion of the AEDN 2530 before the board is fanned out with any with the tray for the valve with the heat spreader will be put in the plane with the place over the layouts of over the area with thereby preventing heat having the ripping up of the rerouting of the fan out of the tray with the functional diagram. One type of the heat spreader shown figure 9126. Silicone dyed and civil component thermally bound with the metal pad with the bottom with a specifically designing and package. The pad is turned thermally with the bottom with either solder or a thermal compound copper area with the top area with the top layer with the PCB. The copper area has an opening solder mass and multiple V with the U to connect with a plain wire with either ground or power depending on the chip design. V with the function of thermal conductors of the heat pipes that allow the heat to flow away from the component. The component dissipate with excessive heat. Plain layers can be mechanically or thermally connected with a large heat sink or the other mounting hardware help to dissipate with the heat. So this shows from figure 9126 of the functional diagram heat spreader. You have your plain layer and the heat pipes on the heat pipes. Your plain layer, your solder mask, your lead and pad component, and the heat flow. Using free V as heat pipe, the heat spreader consists of the free V with the copper with any option of both, in which with the connect with any plane net left or left isolated from all the nets. There are methods for the add with the free V with the PCB. First message used only while routing tray with only one manual routing tool with the free V for the routing tool with the tray with the net to be routed. The plate with at least one vertex with on the board. Right click train with the V with the type from the pop up of the V with selection figure 9127. We'll display some of the desired V with the click OK with the right click again and select the add free V with the from the pop up. The free V with will automatically play with the vertex. Second method, add free V with the dialog box. Click with the place V with the add with the free view. Using add free V with the dialog box. Click the tool menu. Select V with the new. Drop new menu. Add and then free V with the dialog box. Figure 928. Select the desired and show the views of selection. You select V with the 1, 2, and 3. You with the net connection enter the location now. Delete the X and Y coordinates to play with the V with the manually. Click OK. Third method of placing free V with the free Viva matrix tool, which will allow to place multiple evenly spread with the PCB. V is on the PCB with only one command, and the good way to play with the multiple Vibros required with the heat spread with the will with the slash there with the place V with the free V with the matrix tool with the free V with the matrix setting from options menu. Free V with the matrix setting dialog box select with the desired V with the net connection and other vertical horizon space between Vivas. The add edit route mode routing tool will give the draw a box that defines matrix location. Select the you can locate resolution routing grid high enough so that you can more precisely place the box in desired location. So the route gridding option system settings to 5 mils for example. Add free V with the pads act name convert component group number location lock OK or help. Choose the add edit route mode routing tool. Draw a selection on the box. Include the footprint YouTube with the home figure 9130. Draw the box left with the cog with the hold one corner. Drag with the relief to the opposite corner. Finally, select auto play for 3V. The matrix from the menu bar layout will play with the menu of the Vivas with the boundary of the selection box as shown on the can without Viva violating any rules. If the free Vivas are not placed extremely right spot, you can move them using one manual routing tool. Figure 9131A shows result of placing free V of the matrix and moving slightly the V to the required location. Drill layer, ground layers where selected sequentially to show the holes. So now we went to option free V of the matrix setting. Next step is to play with the copper area with over the V with the play with the copper heat strip with the play with the object with the right cool with the select with the new with the pop up the edit obstacle dialog box with the copper area with the obstacle with the type 5 and with the width top of the obstacle with the layer with the ground and net attachment. Click OK. Draw with the box around the free V to define the outline of the heat spreader. Once for the last corner is placed, the right click and select with the finish with the pop up the heat spreader that's shown figure 931B. Click the design rule check button for the check the air with no panels where performed you will get a no connection to plane errors which you can ignore at the moment. If you get the errors related with the free Viva location space for the obstacle space for the manual routing tools to move Viva the obstacle tool resize you may have to make the obstacle grid smaller such as 1 mil to fix the errors. In order for the good thermal connection to occur between the packaging heat spread and openings made with the solder mass, make an opening in solder mass, select the obstacle tool, right click into the new pop up, the right click again, select property display, edit obstacle dialog dialog box and edit optimal dialog box selection. So now we went to auto place and free view the matrix on this one selection box and placing the free view of the matrix. Construction heat spreader shows placement A. Placement A is the heat pipes, and placement B is the copper area obstacles. Copper area obstacle type 5 with the width of the surface mount on top assembly layer, obstacle layer as attachment. Quickly draw the box from the top of the heat strip with a thermal bond made from soldering. Repeat with above the step with the new coppering area of the obstacle except for the specify the obstacle of the SPT stop. Next step of the fan out with the selection V with the 2, fan out V with the V with the 2 from default V with the insert and list and fan out settings, dialog box options, fitting settings, enable the ground. Power net resolve with the net spreadsheet, then select fan out board, auto menu, digital critical trace link with the transmission lines, if the control with impedance can trace if the critical, but they will be routed next. The first step is not to determine which trace needs to be handled with the transmission line, which ones doesn't mention above the digital fiber interfering with the integrated circuit board FOTX U2 was mounted with the analog device ADN 2530 with the data sheet with the digital signal line go to the part with the modulation signals leaving it the part going to the laser diode and handled with the transmission line with the digital control going from the UT to does not have the candles with the transmission line with the only trace left to consider the ones related with the crystal oscillator with and or gates. Literature state with the propagation time PT show with the less than 1/2 of the rise time full time. The PT is greater than process propagation time is less than half of the rise time of the possibility. Better yet, the propagation time is less than 1/4 of the rise time. See the chapter 6 for more detail. So we need to calculate the process and propagation time of the board layout. We're looking up the rise time of the foot F time for the oscillator of the and or gates and for the crystal of the friction. This fictional part here, let's assuming that the rise time and the foot time, fall time, pulse width of 1/4 total period of 66 megahertz square. Under what the assumption of the rise time is 3.98 nanoseconds for oscillator with the typical rise time of the ALS family logic of 1.9 nanoseconds. Critical maximum length is calculated as length trace is less than rise time over K times T. The length trace of the maximum allowed tracing length an inch of the rise time of the single rise time over K. The safety factor K is equal to a minimum of 2 and times the propagation delay time for the board material and PS in inches. Propagation delay with the microstrip, table 6.6 of chapter 6. You have the propagation delay with the board materials equal to 85 over the square root of 0.457 and E plus 0.6 PS1 inches. The critical trace length with the given in table 913 varies of the propagation delay time of the board material indicated with no with the ADN 2530 traces can be treated with the other transmission lines along with no other traces no longer than 3.5 inches. You do not have the treated transmission line. Note that neglecting the length of the cables leaving the board through jumper 1 joint 1 being beyond the scope of the example. Our routing control impedance and table 9.3 show the maximum surface trace lines. Routing control impedance traces objective design for surface microstrip transmission line characteristics impedance 0 base 0 Z 0 base 0 50 ohms. Designing equation of the chapter 6 repeated with equation 3 with the width of the trace is calculated. Wherefore the figure 194 T is equal to 135 mils, H is 10 mils, K is 87 for 15 less than W, greater than W is less than 2.5 mils. And his desired trace width is mils is width of 17.5 mils or 50.9 ohms. So specify the width of the net. Open the net spreadsheet. This first step with the minimum and the maximum width allowed with the net spreadsheet with the intercool tool communication capability to define with the net schematic capture with the toy with the net. Go back with the net spreadsheet layout with the net will be highlighted. Double click with the net name. Display the editing net dialog box. Select the trace width shown figure 914. You can see with the color your preference. With the setting with the tray for the 6 mil, the default good for the small surface mounting pounds, but anywhere from 6 to 20 mils is allowed, which is needed for the 17 mil transmission lines. 914 show the net routing trace settings for the net spreadsheet. If the net name color went mint, convex maximum Minimum count, maximum route enabled. Next to the transmission line, routed manually, cover the edit route mode route tool. Select the net of the YouTube point. Select with the beginning of the route. Figure 9132. Place the vertex just outside of the place outline. Left clicking once. This allows a short thermal relief. 132 show the routing of the transmission line. Place the vertex then the trace width and the next width. During the reflow, short to interfere with the trace and pendant with the right click with the swipe with the change width of the pop-up. Hit the W key on the keyboard, change the width to 17 mils. Click OK, change the routing with the rest of the trace. Begin the second tray for the U2. Continue the tray for the laser dial with figure 9133. Complete transmission line over the pin out with the component with the laser spacing. Dialed length with the trace if it may not be equal. Which of the recommend with the dash sheet. You can use the dimension tools dimension new. Measure the trace little trigonometry to determine the complete tray for the lengths of the traces need to be longer with a zigzag back and forth to make the trace longer. Chapter 6, conserve the acute 90 corners high frequency traces. Move the components accordingly. Example, the top trace within 50 mils longer. Diode laser light diode 1. Move down with the lower trace longer. Bring in the difference in length within 0.7 of the mil. The transmission line running between the microprocessor U1 and U2 are complete with the same procedure once the transmission line had been routed, disabled, locked from nets. 193 show the completed transmission line. Alright, moded or grounded areas for circuit clocks. Clock circuits, the oscillator with the routed neck for the main application of the moded ground plane with around the clock. Circuitry recommended with the prevent stray ground currents affecting other circuits by adding the motive with the ground area with around the oscillator with the trace that should be routed to subside with the required ground area known. Being enabling all of the net association with the clock circuitry, if known, necessary for the capture of the net spreadsheet with the layout to identify the nets described. Route traces manually and automatically. U the route box, U the design one, how the U the route box, figure 9130 show the routed clock trace along with the moat which is described below. 9134 show the clock circuitry routing moded ground. And you can see that in the white how it's put a mode around the rest of it. Routing curve traces. Note the traces between the crystal and the U1 curve of the well with not necessarily for the curved corner of the U with the dimension of the route with the curve trace to choose the one with the manual routing tools. Right click with the curved corner of the pop-up figure 9135. Routing conduct with the curve of the corner of the other corner types, although have a slightly different feel to it. Revert back to regular corners. Right click and select with one of the other corner types. The clock crystal X1 has 4-pin packet of electrical in which it has only 2 pins of the 4 floating pins X1, pin 3, X1, pin 4 can be left floating and be routed to the ground. If the floating pin with the ground plane with the pins may need to be modified with the tube of the pin tool. Select with the pin, right click with the swipe prop at the pop up with the modified connection selection box figure 9136. Select with the ground net. Click OK with the perform the bolt of the pin X1, pin 3, X1. Pin 4. Hit the refresh button, exclamation point, update with the rat's nest, make sure the ground is not enabled. Later, the ground will be poured onto the top layer. X1, pin 3, and X1, pin 4 will be automatically have fan outs. Figure 9135, changing to and from curved corners. Figure 9136, come floating pin of the ground plane. For poor ground plane, occasion for the design rule, check the design reckoning of the connection between the floating pin with the forced ground and the poured ground. The solution fan out with the X1 pin 3 and X1 pin 4 V with the copper pour will be over from the Vivas later. Fan out X1 3 and X1 3, X1 4, manually using only manual routing stock with the net leading from pad route with the trace away from pad about 100 mils. Click once on the vertex, the right click with the select the add free Viva with the regular Viva. Could also be used when the ground plane is poured for the thermal relief. Not desire the Viva the center of the pad has its own thermal release. Remember the Viva 3 was set up earlier in the floodplain's pour. The next step is to etch for the moat over the ground plane around the slack circuitry in the 9134 to etch a moat into the plane layer. Retrieve the obstacle tool, right click with the select with the new from the pop-up, right click with the properties, display with the edit obstacle dialog box, free track, select free track with the obstacle type, set the width of 20, however the wide you want the moat to be with the select with the ground obstacle layer, select with the net layer attachment, click OK to draw with the moat around the clock circuitry shown figure 9134. Make sure to leave the bridge attached with the main ground plane. The bridge should be wide enough to include ground pin with the under of the clock trace for the U1 local ground under of the clock circuitry, where to be attached electrically to the rest of the ground system over the mode. Either the Corel or ground currents back with the ground pin with the integrated circuit with the ground area. The modes will be played with the top bottom layer of the ground switching. Will be even the ground planes before perform. The rest of the boards need to be routed. Disable and lock all routed traces. Enable the remaining unrouted nets. Set the routing grid to 25 millimeters. Auto route the board. Auto route board. Figure 137 results in significant number of either that have been used many of the traces wandering mile. Due for the poor use of the gates assigned with the schematic by swiping gate A and gate C, the routing distance, the number of EVAs can be reduced. Alright, figure 9137, that shows the bad routing caused by poor gate usage. Gates and pin swapping. Two methods can be either the swap pin, gates, and pin. The first is easy for the swap of the gates, the pins, or pins of the on a gate. Schematic page for the run of the engineering change order to layout. This is also the safest way. The second method is the swap pin for the layout of the back annotate capture up to date with the schematic. Well, the second method gates are swapped by swapping ends each of the pins associated with the gate. Gate by gate swapping is available in layout plus version spectra is not discussed here. Second method is described above and demonstrated here, but before doing swamp save the design save of the new max file with the pre-swamp design to be covered in something that goes wrong. First task, unroute with the gates, make sure all of the gates and nets for the enable, all of the other nets disabled and locked, add protection, precaution, design rule check route box can be used to isolate the areas to unrouted. If the design rule check box, change the size of the box view of the zoom design rule check box, then drag the box to Z cursor. Include only the gates U3 and the applicable pins U1. Unroute the tray for the auto unroute and design rule chase route box from the menu. In order to swap pins needed to be swappable, verify the pins are swappable to make the pins swappable. Choose the component tool with the control left click, select with the U3 with the open the package spreadsheet, select the desired pin to the pin group column with the right click, select with the property for the pop-up figure 9138, any integer number for the greater than 0, enable the pin swapping for those pins that restrict with the gates and pins swappable, selecting different integers for each swap group. For example, the enter of 1 pin for the gates A and C and 2 for the B and D. You cannot swap pins or between gates A and D, but you can swap between A and C or between B and D. 9138 shows set pin gate swapping package edit. Once the pins are swappable, gate can be swapped pin by pin. Swap gate A first to gate C. The swap pin for the following 3 to 8, 2 to 10, and 1 to 9. Select with the pin tool. Control left click with the select with the pin 3 with the right click, and then select with the swap for the pop up at the very bottom of the window layout instruction. Second gate with the pin swap. Check with the pin 8 will give it a warning unable to validate the pin swap cannot be back and annotated. Continue to click yes because there is truly under the circuit and circumstances. See the note below. Swap the remaining pins 2 through 10, 1 through 9, use the same procedures. Next step is to back annotate with the swapping information to capture. Stick with the back annotation for the auto menu with the back annotation information box, figure 193, 139. Make sure to take the note of the swap file with the name before you OK you need to file again capture. Figure 193 shows takes the swap and take the note of the swap file name and location. That's right after the annotation has been saved and it's circled there. So note annotate of the swap of the capture remain the project manager with the design icon of the tools menu. Back annotate with the back annotation dialog box browser for correct. SWP file figure 139. Click OK. Figure 194 shows 191 figure 9141 says schematic after pin swapping back annotation operations. Figure 19140 select the SWV for the capture and layout scope of the mode and back annotation file. Figure 9141 schematic after gate pin swap is performed. Now the board can be rerouted to the auto router again. Dumb flag will be needed with clear with the go to the option route straight with the route path with double click with the enable the column, clear the down the flag with the auto routing board with the edit segment mode with the tune clean up the tray for the perform the design rule check with the statistics spreadsheet to make sure that there's no nets have been missed. Disable lock all traces side of the design. Stitching a ground plane with free V of the matrix. The next step is to play with the ground plane to the top of the board using copper pour, remote local ground area around the coxer tree, the anti-copper obstacle. First step is to draw the anti-copper obstacle powering the copper ground. Otherwise, it will be difficult to see the web of the moat is with the ground layer. So the detail of the option system setting to 1 to 2 mil of the anti-copper obstacle of the top layer can be easily played with exactly over the free stack track of a negative ground plane. The anti-copper obstacle closed polygon copper is removed with the inside of the boundary. They make for the top of anti-copper same side with the name negative free track with the ground plane with the anti-copper with the polygon with the outline with the free track with the figure 9-142. Show the anti-copper obstacle showing choose the obstacle with the tool. Right click with in front of the new with the pop with the right click. Again, select with the properties for the obstacle with the dialog box. Select anti-copper as obstacle with the type. Set with the width of 1. Select with the top obstacle layer and leave the net attachment alone. So the outline of the moat area is shown in figure 9-142. One of the last vertex is placed. Right click and select finish. 9-142 show the modes for the top defined with the anti-copper obstacle. Show the free track with the ground layer, anti-copper top layer. Your copper pour now can be placed on the top layer. Choose the obstacle tool, right click with the new pop with the right click, and again with the property edit obstacle dialog box with the copper pour as the obstacle type with the width of 10, set the clearance for the clearance to 20 or tighter if preferred. Select the top of the obstacle layer, so with the ground net with attachment file with the board outline pane, pour copper over the entire board. Finish for the copper power pour shown in figure 194-143 over the gray line, etched copper over the ground plane. 194 shows the finished copper pour over the top layer. Is visible molded edge for the top cover that you repeat the process of the bottom layer with except for the mold that is not required in this case. The last step is for the describe of the ground plate stitching to receive the describe of the plate for the free matrix with the heat spread with the Viva space for the 100-200 mils. Draw a large box over the entire board, and for after a moment should be feel the free veil of Viva the tightly from the top, bottom, inner ground plane shown in figure 144. Perform final design rule check and delete any free Vivas causing errors that have violated the ground moat. Figure 9-144 design and stitch ground plane. And now we're on to miscellaneous items.